Hello everyone, welcome back to the Tech Crux. Today we're embarking on an exciting journey into the world of computer vision, a branch of machine learning that trains computers to interpret and understand the visual world. We'll specifically focus on a fascinating application today that will be emotion recognition using convolutional neural networks, or in short, CNNs. These networks are like a set of digital eyes that learn to recognize patterns in images. This project is a fantastic example of how deep learning can be applied in the field of computer vision to understand and interpret human emotions. Let's start into a brief intro to computer vision before we dive into the code. Computer vision enables computers to see, observe, and process visual data just like humans. It involves techniques that allow machines to extract and interpret information from images or videos. From facial recognition to self-driving cars, computer vision is revolutionizing the way we interact with the world around us. In this project, we'll create a model that detects and classifies human emotions from facial images. So, for every machine learning project, our journey basically begins with choosing the right dataset. And for this project, it will be the same. So in this project, we have used the FER 2013 dataset, which is a collection of grayscale images of various facial expressions, and each image is tagged with the specific emotion. These images are ideal for training our emotion recognition model. You can download this dataset easily through Kaggle. You can go to the Kaggle and type in the FER 2013 dataset, or I will also provide the link to the dataset in the description so that you can refer to that as well. So before we jump again into the code, let's quickly see the how the dataset is, how the images are, how the folder structure for our dataset is. So this is basically how our folder structure is at the moment. So in an archive folder, we have the test and train folders. The test folder has multiple emotion folders. So there will be an angry folder, fear folder. So if I go into the angry, it has a lot of images. It has 958 images with anger that depicts anger of different types. Then if I go to happy, happy will again have a lot of images which will depict happiness in different uh, peoples. So similarly, we have seven different emotions here, and this is the test. And if I go on train, train is similar. We have fear, and here you see there are 4,000 items. Then in happy again, you see there are 7,215 items. So this will be the folder structure that we'll be using for this project. Okay, so that was the folder structure. Now, without any further delay, let us jump into the code and proceed from there. Firstly, we'll import some libraries. So we have OS so that we can read the dataset. We can like travel through the directories. Then we have the OpenCV so that we can perform some pre-processing or we can read the images in the dataset. We have NumPy, we have TensorFlow, we have Matplotlib. So I don't know why NumPy is twice here. Yeah, so we have TensorFlow, we have NumPy. TensorFlow is basically for creating the CNN model for a lot of different tasks, and we are also using Keras library inside the TensorFlow. So and using Matplotlib for plotting the graphs. Now the first step would be loading the dataset. So we have written a function here that reads images, converts them to grayscale and resizes them to a uniform size. The standardization is crucial for our neural network to process the image effectively. I won't go line by line in the code. You can check out the code later on. I'll provide the link to the GitHub repo as well. But I'll go give a high level overview of how the code is working. So in this function, we are extracting the emotions from the folder names and using the enumerate function uh, to give an integer value to each label. After this, we read all the images using CSV, using OpenCV in grayscale and resize them. This is the first level of pre-processing we perform on our dataset. Then after this, we'll have the next level of pre-processing, which involves normalization and reshaping of the images and performing one hot encoding. So one hot encoding we perform on the labels, which basically means that we'll be converting our labels into a format that our model can easily process. So when I was doing this project myself, I found out that the model was overfitting again and again. I was playing around with the CNN architecture, but the model seemed to be overfit again. So what I did was I did some data augmentation to handle that overfitting. It is a very simple data augmentation that we're doing using the image data generator function that is present in the Keras. This augmentation process will increase the diversity of our data, which can improve model generalization, and it will also prevent overfit. So data augmentation basically means that we'll be increasing the data. So if we have, suppose, 1,000 images, we'll be putting some rotations, we'll be changing the heights and widths or the zooms of those images so that we can replicate more such images from the images that we currently have. So this basically includes randomly rotating, shifting, flipping the images during training, introducing a variety of perspectives for the model to learn from. So from a single image, you can create multiple set of new images that will basically be the same, but they'll have some slight variation, so the model can learn better, model can generalize better on the data. These are some parameters which I found to be useful for this project, but you can definitely play around with these parameters to generalize the model better to your needs. Next, then will be our heart of the project, that is the CNN model. We built a sequential model with multiple layers, so including the convolutional layers for feature extraction, max pooling layers for dimensionality reduction, and dropout layers to prevent overfitting. This architecture helps the model to learn complex patterns in the facial expressions. Again, you can play around with the parameters such as the number of layers, kernel, size, activation function, etc., and create a better generalized model of your own. So, and in fact, I challenge you guys to try tweaking this model architecture. Try tweaking the parameters of the image data generator to generalize the model better to get an accuracy which is more than what I'm getting in this project right now. So this architecture is a common structure for CNNs used in image classification tasks. It alternates between convolutional and pooling layers to extract features from the images, applies dropout for regularization, and finally uses dense layers for classification, where we'll be using the activation as softmax. Then the next we'll be compiling our model. We are using the optimizer as Adam. The loss will be categorical cross entropy, and the metric will be accuracy. And we have an early stopping function here. So we are defining an early stopping value. So when the model will be fit, there will be an early stopping. So here I'm putting the patience as 15. So if we don't find the model improve a significant amount after 15 epochs, the model will stop itself and not go beyond whatever it has reached at that point. So after setting up our model and data, we move on to training and then evaluating its performance. So here I have run the model already for you guys, but it will take some time. You see, for each batch, it has taken around, for each epoch, it has taken around 44 seconds, and we have 50 epochs here, so it will take quite some time to run. So be patient when the model is running. And also, since the size of our dataset is huge, when you'll be loading the dataset again, this is just the function calling, but when you'll be loading it actually in this cell, so it will take quite some time to load, so be patient with that as well. So next we have testing. So we are like seeing the accuracy of our model, which is around 56%, which is not the best, but it is decent accuracy for this project, I would say. After that, we use accuracy and loss plots to fine tune and assess how well our model was learning. So right now you see that we have the training accuracy and the validation accuracy, which is quite good, and there's not significant difference between the training and validation accuracy. So when I was doing this, I was first overfitting the model Then when I changed the parameters, it was underfitting, so I had to fine tune it a couple of times before I reached this step. And I stopped at this point, but you guys can go further ahead, fine tune it more, and reach a better accuracy and a better curve as well for this. I'll quickly show you what I was getting when I was doing the project and how an underfit plot looks like, so you can understand better. So this is the underfitted plot that I was getting before, where you can see the training accuracy is significantly less than the validation accuracy, as well as the training loss is significantly more than the validation loss. So this significant difference indicates that there is an underfit model, and the model can be better because you can see the training accuracy was still improving while the model stopped, and so it could have been generalized better where the and it should not have overfit if the parameters were better. We then save our model so that we can load it again for future purposes, and finally let's put our model to test with an actual image and see how it performs in identifying the emotion. This practical application demonstrates the power of deep learning in interpreting human emotions. We do some basic pre-processing on this image so that it aligns with the kind of dataset that we provided our model with when we trained it. So this is the saving of the model, and we are just loading it in this uh, Jupyter Notebook itself, but you can use this model in any Jupyter Notebook. It will be saved on your system now. So I have an image that I'll be loading here, and then we are doing some basic pre-processing again so that the image matches with the kind of data set that we had, and I'll then just put a I'm again using the OpenCV to put this rectangle square box around the face and then showing whatever the result of our model is. And here you can see that I'm using the model. In this I'm using the prediction using the model, and so this was the face that I took from the internet. It obviously is a happy face, and when we ran our model, the model gave us the result with happy itself. So this is how easily we can build an emotion recognition project using CNN. We just need to fine tune the parameters again and again according to our needs. We just take a data set, do some basic pre-processing on it, create a CNN model architecture, perform data augmentation if necessary, and then test our model, save our model, load it again, and then test it on a new image of a person. You can provide your own image here, so you can test the model better. Uh, so that's a wrap on our emotion recognition project, guys. This project not only showcases the capabilities of deep learning, but also opens up avenues for fascinating applications in areas like human-computer interaction, mental health analysis, and more. So if you have any questions or ideas, drop them in the comments below. Don't forget to like, share, and subscribe for more tech and coding content. Happy coding, and see you in the next video, guys. Thank you.